Hey guys, today we're going to talk about some different kinds of reasoning. Again, this is going to feel a little more vocab, English class-like as we get into some of these new terms. The first thing I want you to do though is pause the video for a second and try to figure out the answers to numbers 1 and 2, or example 1 and 2. What are the next two numbers in the pattern? And then sketch the fourth figure. As always, use a straight edge on that figure. All right, hopefully you paused it and are back with me. The next two numbers here should be 37 and 45. How do we get there? You should have noticed that we were adding 8 every time to get to those next two numbers. All right, let's look at example 2. I would bet that most of you have a rectangle cut in half this way, and then you have split it into 4 sections this way for a total of 8 boxes and shaded this bottom corner. If you did that, you're almost correct, but you're missing one piece. We always want to make sure we're paying attention to the details here, and all of these are labeled figure 1, figure 2, figure 3, so we need to label figure 4 as well. Both of these are examples of inductive reasoning. And inductive reasoning just means uses patterns to make conjectures. Uses patterns to make conjectures. So now we need to talk about what that conjecture word is. So a conjecture is an unproven statement based on observations. So we use those patterns to make an educated guess on what those next two things would be or the next figure would be. Example 3, here's a conjecture. If you're not feeling well, then you have a sore throat. Is this statement true or false? Well, it could be true, but it's not always true, so we're going to say that that statement is false. Then we have this vocab term counterexample. So a counterexample is a specific example that proves a conjecture false. So going back to our previous example, we need a specific example. So if you're not feeling well, you have a sore throat. Well, what else could you have? You can't just say, oh, you just, something else can be wrong. That's not a counterexample. We need something specific. You could have a stomach ache. You could have a headache. Lots of different things could be wrong, but you have to give that specific example. So headache, stomach ache would be those specific things. Conjecture, for example, 4. The sum of two numbers is always greater than the larger number. Again, pause the video. Write down what you think, true or false. If it's false, give a counterexample. Hopefully you're back with us. I'm going to say this is false. Why is it false? Well, I could use a negative number. So if I have -4 and I add 6 to it, I get 2. In this case, 2 is not greater than 6. So that is a specific example that proves that that statement is not true, that proves it false. All right, we have another kind of reasoning here, and it's deductive reasoning. So inductive reasoning uses patterns. You want to look for that keyword of patterns. You're making those educated guesses. Deductive reasoning uses facts and definitions to make a conclusion. Deductive reasoning uses facts and definitions to make a conclusion. So an example of deductive reasoning is right there. If the measure of an angle is 90 degrees, then it is a right angle. The measure of angle A is 90 degrees, and since we know that, therefore, angle A is a right angle. Based on what we've talked about, I'd like for you to pause the video right here and try these 4 statements. You are determining whether or not, or whether these are inductive or deductive reasoning examples. Okay, hopefully you are back with us. So, the rain stopped and the sun came out. Next, a rainbow will appear. So when I'm thinking through this, yeah, usually that happens. There's quite often a rainbow after a storm, but not always. So we're using patterns to come up with that reasoning. So that is inductive. Jose put $25 into savings each week for 10 weeks. Therefore, Jose has put $250 into savings during this period. This one to me is very factual based. So this is deductive. Quadrilateral RTGL is a rectangle. All rectangles are parallelograms. So quadrilateral RTGL is a parallelogram. I would say, once again, we're talking facts. So this is deductive. All right, this last one. The first 3 numbers of a pattern are 1, 2, and 4. So the next number is 7. As soon as you see this word pattern, it should be a big red flag for you that that is going to be inductive reasoning. Okay, example 6 says, tell what you can conclude from the 2 pieces of information. Once again, pause the video right here. Try these 4 examples on your own. All right, if you are back with me, Mary is a veterinarian who adores all dogs. King is Abby's dog. Therefore, we want to know what we can conclude about Mary. So if Mary adores all dogs and King is a dog, then we know that Mary adores King. If you don't have that wording exactly, that's okay, but something close to that is what you should have. All right, if you play the clarinet, then you play a woodwind instrument. If you play a woodwind instrument, then you are a musician. Okay, so we're going to kind of skip around here. If you play the clarinet, you play a woodwind instrument. You play a woodwind instrument, you're a musician. So if you play the clarinet, then you are a musician. Okay, triangle ABC is an obtuse triangle. Angle B and angle C are acute angles. Therefore, well, if you know an obtuse triangle has to have at least one obtuse angle, and it can only have one obtuse angle. If we know B and C are acute, then angle A is an obtuse angle. Dennis went swimming at the public pool. No one is allowed to swim there without first taking a shower. Therefore, we know that Dennis took a shower before he got into the pool. All right, guys. As always, if you have any questions about this, please come in and see me. I will see you in class.